Welcome back to part 2 of Dave Does Exponential Functions from Home. In the last video, we just finished talking about like the most basic kind of transformation, where we shifted an exponential graph down 4 units by subtracting 4 from the function on the back end. So as a quick sort of follow-up to that, I want to talk about y equals 5 to the x plus 2. We saw in the last video that a minus 4 back here shifted the whole thing down 4 units. The y-intercept is usually at 0, 1. The new one ended up at 0, -3. The horizontal asymptote is usually at y equals 0. It ended up in the last one at y equals -4 because it got shifted down 4 units. And then the shape of the graph didn't really change. Had the same shape, same basic structure. I think we can probably get away with just doing the same thing here. This is my transformation. It means it's going to take us up 2 units. This is my base graph. It means it's going to be an exponential function with the original intercept should be at 0, 1. The original asymptote is going to be at y equals 0. So those are the things that I'm going to edit with this transformation. And we'll see what kind of graph we get. Okay. So my standard y equals 0 asymptote is going to move up 2 units. And it's going to land on this line right here, y equals 2. That'll be the new asymptote. My standard 0, 1 intercept is also going to move up 2 units. So it's going to land right here at 0, 3. And other than that, the graph is going to have pretty much the same shape. It's going to have a horizontal asymptote on the left and a big swooping upness on the right. Probably hits, what is this point? Should be 1, 7, I think. If you plug 1 into this, you should get 7. So this is sort of the goal of this section. Making a table of values is a great way to explore an idea for the first time and give yourself a sense of what's happening and why it's happening. But the goal for this is to be not making a table of values every time. The goal, hopefully, is you get so comfortable with the idea of this transformation being a shift up 2 units, and you're already so comfortable with the idea of an exponential function having this shape that you just kind of draw the shape with this transformation. That's the goal. Ultimately, by the end of this, we want to be skipping the part where we're doing tables. We want to just look at the transformations, draw the graph. To that end, let's talk about a few more kinds of transformations. Something like y equals, let's say, 1/2. I'll go back to 3's for this one. 1/2 of 3 to the x. So this is my base function. This is my transformation. This time I'm not adding anything, I'm just multiplying by something. So since this is a new one, we'll make a table of values. We'll do an x. I'm going to make a 3-column table again. So I can separate the base function activity from the transformation activity. So I'll use the standard 5, -1, or -2, -1, 0, 1, and 2. And this is still the same. 1/9, 1/3, 1, 3, and 9 are the outputs you get when you use these numbers as exponents on top of 3. Now I'm going to cut these in half. So this will be 1/18. this will be 1/6, this will be 1/2, this will be 3/2, and this will be 9/2. Some of this section is going to involve a lot of fraction arithmetic. I hope that you're comfortable with that. So, let's make ourselves a table. 1, 2, 6, 7, 8, 9. Okay. I'm going to start by drawing the untransformed original base graph in blue so that we can sort of see exactly what's happening. So in blue, the untransformed version of this goes through 0, 1 like they all do. It's 1, 3, and 2, 9. And then back here it's 1/3 and 1, 9. So this is the original untransformed base graph. Y equals 3 to the x. So now I'm going to graph the transformed version of it on the same set of axes so we can see exactly what changed here. The transformed version isn't going to go through 0, 1, it's going to go through 0, 1/2. So it'll be down here. This one will be 3/2, this one will be 4/2. This will be 1/6, and this will be 1/18. So hopefully this makes it pretty clear that this transformation is making this thing half as tall. What used to be 3 is now 3/2. What used to be 9 is now 9/2. It's probably a little more difficult to see on the back end, just because there's not a lot of room here. But trust me that this is half as tall. This blue dot here is at 1/3, the black dot is at 1/6. Whatever this distance from the y-axis used to be, that distance has been cut in half, which sort of makes sense. This is the original y value. You cut it in half literally to get the new y value. So it makes sense that this is just a cutting in half. I refer to this using the words vertical squish, because it's getting squished, it's getting shorter. 1/2 as tall. I think the official fancy math words that the book uses for this are compression. Compression. It's a fancy word for squish. So, that's multiplying by a 1/2 on the outside. Let's examine what happens if we multiply by a big number on the outside instead of a 1/2. And let's also look at what happens when we multiply by a negative on the outside at the same time. Let's do 2 at once. Again, I'm going to put the original untransformed base function in blue. The untransformed base function has an asymptote there, has its intercept at 0, 1, and it does the swoopy thing up to the right. I feel like it's safe to judge from the last example. We multiplied by 1/2 and something got half as tall. Here, if we multiply by 4, it feels pretty safe to just say that this is going to get 4 times taller. So whatever this distance is, this is 4 times that distance. Green is 4x taller. Blue is the base. Y equals 3 to the x. We'll get red for the negative. Multiplying by a negative means whatever these y values were, we're going to make them all negative. So that's going to cross the axis down here. It's still going to have the same horizontal asymptote. It's going to go down instead of up. So this is the 4x taller transformation. This should have written words before I tried to draw that shape. This is the flip upside down transformation. I call this a stretch. I call this a flip. The book calls this a reflection, which seems like an unnecessarily fancy word for flip. So, that's what happens when you multiply by something in front, and we've already covered what happens when you multiply, or when you add or subtract numbers on the back end. There's still a couple more we got to do, but they're gonna get kind of weird, so I'm going to cut this video right here and give myself an entirely new, fresh video to talk about how weird they are.